Hello guys, welcome back to Knowledge is Power Academy. In this video tutorial, we're going to be looking at these practice problems I have here. This one and this particular one, all right? So let us start with this one, all right? Now, in this question now, it says, state whether each of the following statements is true or false. Now, what are the following statements? It is actually this statement, all right? So we are asked to state whether it is true or false. So if we read this one now, if it is true, we attach true. If it is false, we also attach false. Now, this one is read this way. Pi is an element of Q. Of course, Q is a rational number, all right? So pi is an element of a rational number. So is it true or false? It is actually false. Next one, minus 3 is an element of a natural number. It is also false. Next one, 3 is an element of integer. It is true. Next one, root of minus 1 is an element of irrational number. It is false. Next one, 7 is an element of prime number p. It is true because 7 is a prime number. All right. Now, next one, square root of 9 is an element of natural number. It is true. All right. Next one, minus 5 is an element of integer. It is true. Next one, cube root of 2 is an element of irrational number. It is true. Then the final one under this particular question says 2 is an element of rational number. It is false. Okay, now next one. This particular one now, we're asked here to determine the elements of the following sets. Of course, if you've not accessed my video, my first video under this playlist that says, that has to do with that, there in that video, I actually treated how you can convert set builder method into listing method. In fact, I taught extensively on the concept of set builder method and listing method of a set. All right. So if you have a set in a set builder notation just like this, you can be able to convert it in listing notation. So here in this particular one we have here, we are given these sets, set A, set B, and set C, all in set builder notation. And we are asked here now to determine their elements. In other words, write out these three sets in listing notation. All right, so let us go. For the first one now, I want you to understand this thing very well. This particular one is read this way, that A is set of x such that x is equal to 2 raised to power n and n is an element of n. So this small letter n means the members of the natural number. Very important. So now for us now to do this, so what this thing actually means in essence is that the element here is x, but this x is actually 2 raised to power elements of natural number. And this natural number now has a limit. N means natural number, meaning that you are going to pick any natural number, put it inside this formula that says 2 raised to power n. Whatever thing that will be the output or the outcome will be the elements that will be in here. And of course, what is a natural number? Natural numbers are actually those numbers on the number line starting from 1 down to positive infinity. So 0 is not a natural number, and all the negative numbers is not a natural number. So I'm going to pick any number on the natural number, or I'm going to start from 1, 2. All right, numbers on the number line ranging from 1, just like if this is a number line now, for instance. So meaning that if this is a number line, for instance, and here is 0, here is 1, here is 2, here is 3, here is 4, and here is minus 1, here is minus 2, here is minus 3, here is minus 4. Then from this 0 now, of course, from this 0 towards the right is towards the positive infinity, and from this 0 towards the left is towards the negative infinity. So natural numbers are actually those numbers that ranges from 1 down to positive infinity. All right, so those numbers are what we call natural numbers. So what it means now, coming to this particular question now, we're going to say that A is set of. Now, the elements that are going to be in here will be the outcome of 2 raised to power any of the natural numbers. So we're going to be starting from 1. We're going to pick 1. Of course, the natural numbers being numbers from 1 down to positive infinity means that it will not really end. It will continue. All right. So in that case, now taking 1, put 1 inside 2 raised to power n. All right. So put 1 here, it will be 2 raised to power 1, which is equal to 2. Put 2 here, it will be 2 raised to power 2, which is equal to 4. Put 3 here, it will be equal to 8. Put 4 here, it will be equal to 16, and so on and so forth. All right. Therefore, the element of this set A is actually 2, 4, 8, 16, and so on. All right. Okay, so it actually continues, it does not end. Very important. Now, what about the next one for set B? Now, set B goes this way. Now, B is read this way, that it is set of X. All right. Set, of course, this curly bracket is read at set. All right. Set of X such that this column means such that X is equal to 3n. Now, n is an element of a natural number. So in this case, now the formula is more like 3n. And now n will be all of these natural numbers from 1 to positive infinity. All right. It will be from 1 to positive infinity, just like we have seen initially. Now, what we are going to be doing next now is we are going to pick 1, put it in here. So put to be 3 into 1, which is equal to 3, 3 into 2, which is equal to 6, 3 into 3, which is equal to 9, 3 into 4, which is equal to 12, and so on and so forth. So the element now is actually going to be 3, 6, 9, 12, and so on, because natural numbers will never end, because remember it started from 1 down to positive infinity, so it does not finish. So it means that we can just write down a few and put 3 dots, meaning that it continues, it does not really end. Now, next one, C. Now for set C, which is read this way, set of X such that X is equal to 3n, and n is an element of Z. Of course, Z here means integer. And now this thing that looks like A, that is upside down, is read as and. It means and, A-N-D. Now, and n is less than 3. So in this case now, n does no longer mean natural number here. N means integer here. Now, what does integer mean? Integer is nothing but, now the same way we have a number line like this. In this number line you see here, integer means all the numbers on the number line excluding 0. So 0 is not an integer. So all the numbers from 1 down to positive infinity, they are all integers, precisely known as positive integers. Again, the numbers on the number line from -1 down to negative infinity, they are all integers as well, precisely known as negative integer. All right. So now what we are told that the condition here is that n is less than 3. So it means that since it is less than 3, look at it, less than positive 3 actually. So less than this positive 3, it means that the value of n is actually going to be all the number from 2, because 3 is not included. All the number from this positive 2 down to negative infinity. So it means that for us to get what will be in this set of numbers, it is X is that element which is equal to 3n, and n itself is actually from 2 downwards. All right. So it is actually from 2 downwards. So what we are going to do now is we are going to first, in this 3n as the formula, all right, in this 3n as the formula, we are going to pick positive 2 and put it in here. So it will be 3 into 2, which is equal to 3. Next one is going to be 3 into 1, which is equal to 3. All right. Next one is 3 into, okay, 0 is not among, 3 into -1, which is -3. Next one, 3 into -2, which is equal to -6. Next 3 into minus 3, which is equal to minus 9. Next 3 into minus 4, which is equal to minus 12, and so on and so forth. So it keeps on going and going and going, because now once we've gotten to the negative values, it continues, because it will actually range from negative infinity. Since we are talking about integers ranges from, integers includes all the whole numbers on the number line excluding zero. So it ranges down to negative infinity. All right. So what it will now mean, how we are going to arrange this one now, since all the negative values, since all the negative integers are all included, what we are going to do here is we are going to put 3 dots. These 3 dots will include the avalanche of negative integers. Then we are now going to say minus 12, minus 9, minus 6, minus 3, minus 3, then 3, and 6. All right, I hope you understand this. All right, so this 6 is the answer when we have 3 into 2. All right, 3 times 2. Then this 3 is gotten when we say 3 times 1. This minus 3 is gotten when we say 3 times minus 1. Then this minus 6 is gotten when we say 3 times minus 2. Then this is 3 times minus 3, 3 times minus 4, and so on and so forth. All right, so this is the set in listing. Now this is the set builder notation, and this is the listing method. This is the set builder notation. This is its listing method. This is set builder notation, and this is its listing method. It is very important we understand how to interpret from set builder notation down to listing notation. All right, so that is it for this particular video. Please do well to share your thoughts and observation in the comment section below. I'll be forward to reading through them. Thank you, and don't forget to subscribe to our YouTube channel, like and share.